Toyota is working on a car that could run using water. Yes, you heard that right. Water would go into the fuel tank instead of petrol. If this technology becomes successful, it could completely disrupt the automobile industry, including companies like Tesla, which currently claim to produce the most eco-friendly cars. Toyota's new engine is designed to be a combustion engine that is also extremely environmentally friendly. In this concept, water goes into the fuel tank, and water also comes out of the exhaust. Yet the engine is still capable of producing power comparable to petrol or electric engines. This raises an obvious question. How can Toyota possibly burn water inside an engine? Have they discovered some special property of water that other companies have overlooked? Normally, water is considered one of the biggest enemies of a car engine. If water accidentally enters the fuel tank or engine, it can cause serious damage. Metal components can corrode, and the engine's condition can deteriorate quickly. So how does Toyota plan to turn something that usually damages engines into a helpful fuel source? Another interesting question is why Tesla is currently seen as the trendsetter in the electric vehicle industry, even though Toyota has been involved in this space for much longer. The truth is that Toyota actually launched the world's first successful hybrid electric car back in 1997. In many ways, they helped bring electric vehicles into the mainstream long before Tesla became popular. So why isn't Toyota leading the electric vehicle revolution today? And why are they now trying to pioneer something as unusual as a water-based engine? Could it be that Toyota sees something others, even visionary entrepreneurs like Elon Musk, might be missing? To understand the answers, we need to understand Toyota's mindset. Toyota has never been a company that simply follows trends. Instead, it prefers to create them. Many of the innovations in the automotive industry have come from Toyota's focus on one key principle: innovation. Back in the 1990s, when most of the world wasn't even seriously thinking about electric vehicles, Toyota introduced the first mass-produced hybrid electric car, the Toyota Prius. This car played a huge role in starting the global conversation about cleaner transportation. In fact, some experts believe that if the Prius hadn't been successful in the late 1990s, companies like Tesla might not have received the same early momentum in the 2000s. However, despite the success of the Prius, Toyota itself was not completely satisfied. Even today, in the United States, a country that is home to major car manufacturers like Tesla, Ford, Chevrolet, and Fiat, Toyota is still considered one of the most reliable car brands. This is one reason why a significant portion of off-road vehicles in America are made by Toyota. When the Prius was launched and feedback from around the world started coming in, Toyota carefully studied both the positive and negative responses. During this process, they noticed several concerning issues with hybrid and electric vehicle technology. Because of these concerns, Toyota slowed down its EV development for a while. But what were these issues that couldn't simply be fixed with small improvements? When Toyota examined the Prius and other EV models more closely, they identified two major problems. The first problem relates to how electric vehicles are powered. EVs are often considered completely eco-friendly because they produce zero emissions while driving. However, the electricity used to charge these cars often comes from power plants that burn coal, diesel, or natural gas. This means that although EVs don't emit pollution directly on the road, pollution is still being generated elsewhere to produce the electricity they use. The second issue involves the batteries used in electric vehicles. EV batteries are typically made using materials such as lithium, cobalt, and nickel. Extracting these metals requires large-scale mining operations that consume massive amounts of fossil fuels. In fact, producing a single EV battery can require so much energy that the carbon emissions generated during manufacturing can be extremely high. Some estimates suggest that an electric car may have already produced more than 13,000 kilograms of carbon dioxide even before it reaches the showroom floor. When Toyota looked at these factors, they realized that the core purpose of EVs, protecting the environment, might not be fully achieved under current conditions. Instead, large amounts of rare materials and energy are being consumed simply to maintain modern convenience. Because of this realization, Toyota decided to slow down its focus on fully electric vehicles and instead concentrate on improving combustion engines. One of the key areas they began focusing on was fuel. Toyota understood something very important from the beginning. The type of fuel used in an engine can matter even more than the engine itself. The chemical structure of the fuel determines how much energy it can release, how easily those chemical bonds break during combustion, and how much pollution is produced in the process. All of these factors play a critical role in determining how efficient and environmentally friendly an engine can be. In this situation, many of you might already know which element forms the most chemical bonds. The answer is carbon. Because of this property, most fuels we use today, such as ethanol, kerosene, or CNG, are carbon-based. When these fuels are burned, they almost always release carbon dioxide in one form or another. So the question becomes, what alternative fuel could avoid this problem? One possible answer is hydrogen. A hydrogen molecule, known as H2, contains two hydrogen atoms. Because hydrogen molecules are extremely small, they can be packed very tightly inside a fuel tank. This means a tank can store a much larger number of hydrogen molecules compared to petrol molecules. To understand this simply, imagine filling a fuel tank. With petrol, a small number of molecules might provide a certain amount of chemical bonds that release energy. But because hydrogen molecules are smaller, you can fit far more of them in the same space. Even though each hydrogen molecule contains fewer bonds individually, the total number of bonds, and therefore the total potential energy, can become much higher. Another advantage is that hydrogen bonds are very strong. When they break during combustion, they can release significantly more energy than petrol. In fact, hydrogen combustion can produce several times more energy than petrol. At the same time, it does not produce carbon dioxide as a byproduct. From an environmental point of view, this sounds like a perfect solution. Toyota has already explored hydrogen engines in the past, and detailed explanations of these engines already exist. However, as mentioned earlier, hydrogen-powered engines also come with serious challenges. Hydrogen is not only a promising fuel, it is also highly flammable. Storing large amounts of hydrogen in a vehicle means carrying a tank filled with an extremely explosive gas. In simple terms, it can be compared to carrying a moving time bomb. Imagine hundreds of hydrogen-powered cars stuck in traffic in a crowded city like Mumbai. The risk factor would be enormous. Any major accident could lead to catastrophic consequences. Because of these safety concerns, Toyota initially had to abandon the idea of hydrogen-powered engines. But the story didn't end there. Toyota eventually went back to the drawing board, this time with a different approach. The company had already realized something important. If any fuel besides fossil fuels could power truly eco-friendly vehicles, hydrogen was still the most promising option. So instead of starting from scratch, they asked a different question. What if the problems with hydrogen engines could simply be solved? Yes, pure hydrogen is extremely flammable. But what if hydrogen could be used in a less pure form? If hydrogen were combined with other elements in a stable way, it might reduce the risk of explosion while still allowing the energy of hydrogen to be used. This line of thinking eventually led to the concept of a water engine. Before moving forward, it's worth understanding an important lesson from this story. In fact, this is one of the most valuable ideas to learn from Toyota's approach. Whenever we face a problem in life, just like Toyota did, It helps to rely on something called first principles thinking. First principles thinking means breaking a problem down to its most fundamental level and identifying its true root cause. Toyota realized that the main issue wasn't the hydrogen engine itself. The real problem was the explosive nature of pure hydrogen. If that single problem could somehow be controlled or modified, then it might be possible to enjoy the benefits of hydrogen fuel without its dangers. Creative breakthroughs often come from this kind of thinking. When people face challenges, they usually become stressed and start looking for the easiest escape route. As a result, many promising ideas get abandoned too quickly. Now, let's return to the concept of the water engine. No matter how pure water appears, from a chemical perspective, it is actually made of hydrogen and oxygen. If we think about hydrogen as the fuel, water can be considered hydrogen that contains an impurity, oxygen. Interestingly, this oxygen actually helps stabilize hydrogen and prevents it from being dangerously explosive. Once Toyota understood this concept, they realized water might hold the key to using hydrogen more safely. However, there was still another challenge. This is why today, whenever we hear that Japan or a company like Toyota has developed a new technology, people instantly become curious. There is a global expectation that something interesting and innovative might be coming. Now, hopefully, this story also gives you some inspiration and new ideas for your own life. But one important question still remains. Can Toyota's water engine actually replace electric vehicles, especially today, when EVs already hold a significant share of the market? At the moment, Toyota's water-powered engine is still at the conceptual stage. Only a prototype has been revealed, and detailed technical information is limited. Because of this, it's difficult to make a definitive judgment. However, based on what we currently know, Toyota will need to solve at least two major challenges before this technology can become practical. The first challenge relates to energy flow. In this system, a battery is used to split water into hydrogen and oxygen through electrolysis. The hydrogen is then used to power the engine and rotate the wheels. As the wheels rotate, they can act like a generator and convert some of that kinetic energy back into electrical energy, which helps recharge the battery. However, if the battery keeps charging itself without any external energy input, for example solar panels or another energy source, it would effectively become a perpetual motion system. According to the laws of physics, a true perpetual engine cannot exist, so this part of the system would need careful engineering to work realistically. The second challenge involves energy efficiency. Burning 1 kilogram of hydrogen can produce about 121 megajoules of energy. But generating that same kilogram of hydrogen through water electrolysis typically requires around 180 megajoules of energy. In other words, the process currently consumes more energy than it produces. There is still hope for improvement, though. An electrolyzer company in Australia has recently developed a system capable of producing hydrogen with about 95% efficiency. Innovations like this could significantly improve the viability of hydrogen-based technologies in the future. Still, two key questions remain. How will Toyota solve the energy balance challenge? And how affordable will this technology be for everyday consumers? The answers to these questions will ultimately determine how strong Toyota's water engine could be as a competitor to electric vehicles. Even so, the potential is definitely there, especially when a company as large and technologically capable as Toyota is working on the idea. Before we end, here's something interesting. Just like Japan focused on innovation in manufacturing, another country is now trying to revolutionize air travel. That country is the United States, and more specifically, its space agency, NASA. Through a commercial aviation initiative, NASA is working on a new type of aircraft expected to launch around 2028. With just one major design change, this aircraft could potentially reduce the cost of air travel by up to 30 times. But what exactly is that design change? And why is NASA, an organization known for rockets and space missions, working on airplane technology? I've explained the entire concept in another video where we explore how this innovation could completely transform the future of air travel. That's all for today's video. Hopefully this discussion introduced you to some new ideas, creative concepts, and a broader perspective on technology and innovation. If you enjoy content like this, consider subscribing so you don't miss future videos. Until next time, stay curious, keep learning, and keep growing.